Hey guys, Mr. T here, just doing a quick video on finding or drawing the line of best fit by eye. If there's a strong enough relationship between two variables, it's reasonable for us to draw a line to best fit the relationship. So when we say strong enough, we actually mean a coefficient of determination, so r squared, that's greater than 0.7. So r squared greater than or equal to 0.7 is when it would be appropriate to draw a line of best fit to represent data. So the next topic, you're actually going to learn to draw a line of best fit with line equations like we did in the second topic of this year. But for now, you're going to draw a line of best fit by eye. You should only do this for our purposes if you're running out of time in your test or your exam and you need to draw a line of best fit really quickly, because ultimately I want you to draw a line of best fit using line equations. But if you're running out of time, you can draw it a bit quicker using this technique. So, what are the steps? You need to find the mean x bar of your x data values. So, for example, if this was my x data, I would find the mean of these numbers, or the average. You add them all together, divide by how many there are. 2, you need to find the mean y bar of your y data values. So you'd find the average of all of these. This x and y bar, so I should have written bar there. This x and y bar form the coordinates of the mean point on your scatter plot. For example, x bar, y bar separated as a comma. It's like a coordinate there. So what you do then is you plot all the data points on your scatter plot. Then you plot the mean point, x bar, y bar, on the scatter plot. You need to clearly mark it. I suggest using a different color, or just make a really big dot, so it's very clear to the reader what you're doing there. It's a mean point. And then 6, draw a line through the mean point so that the number of data points above and below that line are about the same. So essentially what you'll do, you draw a line, you'll put your ruler on the mean point, and then you'll pivot around so that the data points, there's an even number of dots above and below that line that you're pivoting. So to show you how that works, I'm going to try on this iPad screen. I'm going to do a line of best fit by eye through the scatter plot of the data below. So this was from the class. We had the age in years of kids and the distance they threw a discus in meters here. So what I'm going to do, if I know that I want to draw a line of best fit by eye, I need to find the mean point. And to find the mean point, I need the mean x and the mean y. So to do that, I find the mean of the age data, which was 12, plus 16, plus 16, plus 18, plus 13, plus 19, plus 11, plus 10, plus 20, plus 17, plus 15, plus 13. There's 180. 180 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Over 12 bits of data. That's 15. So the x bar is 15. Let's do y bar now. So add these numbers together. They're going to be bigger. 20 plus 35 plus 23 plus 38 plus 27 plus 47 plus 18 plus 15 plus 50 plus 33 plus 22 plus 20. That is 348 over, same number, 12. Divide by 12, that's 29. So my mean point, x bar, comma, y bar, is going to be 15, comma, 29. So the next step was plot all your data points on the scatter plot. So I need to put these data onto my scatter plot. Now, the discus distance isn't going to cause you to age. So the age is the independent variable. So that's going to need to go on the x-axis, age in years. And the y-axis is going to be the distance thrown. In meters, and I can start plotting these. So it's 12 and 20, 12-year-old, through it, 20, there's my cat going again, 16 and 35, 16 and 23, so a bit of a weaker 16-year-old. 18 and 38. 13 and 27. That's a strong 13-year-old. 13 and 27. 19 and 47. 45. 19 and 47. Is that 11? I just need to move the screen. And yeah, 11 and 18. 10 and 15. 20 and 50. 17 and 33. 15 and 22. Oh. 15 and 22, just under there. 13 and 20. Okay, I'm going to plot my mean point now, which was 15 and 29. I'm going to do it in red. 15. My mean point is there. So my goal, let's do the steps. Plot the mean point, draw a line of best fit through the mean point, so the number of data points above and below it are about the same. So what do I mean by that? Black line. This is a line going through the mean point. Okay? Now let's count the number of points above it. 1, 2, 3, 4, 5. There's 5 above it. How many are below it? 1, 2, 3, 4, 5, 6, 7. So they're not even. So what I need to do is I need to grab my ruler and twist this line around a little bit so that there's a couple more under it, and then it might even it out. So what I could do, this isn't the most intuitive thing. What if I did that and went there? What do we have now? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Well, I just flipped it around this time. So you need to massage this line a little bit to get it. What you could also do is put the points on the line so they're neither above nor below it. So I'm going to try that. So it still needs to go through the midpoint, but I think I've got this on the, so that's neither above nor below. So now I've got 1, 2, 3, 4, 5, 6 above, and 1, 2, 3, 4, 5 below. Still no good. Maybe I could, because this board seems to be adjusted a little bit more. Here we go, I've got 2 dots on the line of best fit. I'm still on the mean point. Now what do I have? 1, 2, 3, 4, 5, 6 above. 2 on, so they're neither above or below. 1, 2, 3, still 4. So what you can see I'm trying to do here, not very well because I don't actually have a ruler on the screen. I'm just moving this line. It's not like I could pivot it like a ruler. I'll go more extreme this way. 1, 2, 3, 4, 5. 1, 3, 4, 5. That seems a bit better. I'm going to try to put these two. And also remember these dot positions, because I'm on this slippery screen, they're not exactly in the right place. So I'm just going to do my best with what I've got. Let's count here. 1, 2, 3, 4, 5 above. 2 on. 1, 2, 3, 4, 5. There you go. There's your line of best fit. It's going through the mean point. it's got an even number above, an even number below. And you can see that this line of best fit sort of represents the relationship of the data points pretty well. You got some far here, some far there, but the majority of them are quite close. Okay, so that's doing a line of best fit by eye. Now for the second part of this video, it's the idea of interpolation and extrapolation. The line of best fit actually tells us the direction the data points appear to be going. So the line of best fit can actually be used to predict where data is that we do not have, where it should actually lie. So a line of best fit can be used to predict where data that we do not have should lie. I did write that properly, I'm just rereading it to myself. So for example, on the data plot above, the line of best fit predicts that if someone was aged 14, they should throw how many meters? Well, I'm going to go up here. We don't have a 14-year-old here. But at 14, the line of best fit is here. So 25, it's about 26, okay? So you can see the line of best fit there is predicting that a 14-year-old, which is data we don't have, should throw 26 meters. But keep in mind that that 14 is within the lowest and highest data points in the data, so it's a reliable prediction. 14 is within our lowest data point is at 10, lowest, and our highest data point is at 20, highest. And so we've got data from 10 to 20, so it's not a big stretch for us to predict within that data because we've got data surrounding it, right? That's pretty reliable, okay? So predicting data points within the existing data set, that's known as interpolation. Inter means within. Interpolation is reliable if there's a strong correlation between the variables. You can see from those dots above that they're pretty close together and they seem to be sitting pretty close to a line. But on the other hand, predicting data points outside the existing data set, that's known as extrapolation. So I'm going to write on this diagram. Predicting between 10 and 20, that's interpolation. And that's green because it's okay. Reliable if R is, reliable if R squared is high. Close to 1, okay? However, extrapolation, which is predicting outside, is much less reliable because you don't actually have any data telling you what direction the points are going to go. Your data stops at your highest and lowest. You don't know where the dots are going below or above that. So, as an example here, do I really know that the line is going to continue up in that direction? What if the dots suddenly started straightening out? What if it drew a Regan squiggle or something, or a smiley face? We don't actually have the data to prove that it goes in a straight line. So that is extrapolation. And that is not reliable. This is extrapolation down here too. Why is it extrapolation? Because I don't have any data below 10 years of age. So I'm just guessing below here that the line is going to still go straight diagonally like that. Okay? So extrapolation should only be done if the correlation is extremely strong. So if your R squared is greater than or equal to 0.95. If I look at these dots here, this doesn't look like a 0.95. It's quite spread out. So extrapolation wouldn't be safe or reliable to do here. And also, you can only extrapolate if the data point being predicted is not very far from the lowest or highest data points we have. So what I mean by that is even if your data points were all along the dots, it's only safe to extrapolate if you're predicting a dot just outside the highest or just outside the lowest. If you're predicting really far from the existing data, that's not reliable either, even if the data was perfectly on the line, because we really have no information between your highest and that far point that you're predicting. Okay, so there's two conditions there that have to be met if extrapolation is okay. If you don't meet any of these two predictions, extrapolation is not reliable. I actually used to say extrapolation is never reliable, but I've softened up a bit on that. It's not reliable unless you have these two conditions, and even then you shouldn't be comfortable with it. Okay, so hopefully that helps you out with drawing a line of best fit by eye and interpolation extrapolation. And see you in the next video.